Alright, welcome to the video. I just want to provide an update on something I've been working on, which is a dynamic pipeline executor. And I've been working on this chess project for the last few months, and we've been incrementally producing updates in order to enhance the pipeline. And I think the latest place we got to it is essentially baking in all of the Python scripts and the Python requirements directly into a Docker image. And I've already declared in earlier videos that this is not really the ideal way of doing things because you have to maintain lots of Docker images. So whenever you update your Python code or your Python requirements, you're now going to have to go through a process of re-imaging all of your Docker images and pushing them into the artifact registry so everything is up to date. And what I'm proposing here is a more dynamic way of executing your pipelines that in a way that you're only concerned about updating the code and you're not worried about updating any of your Docker infrastructure. So it goes a little something like this. Everything is the same as before. We have a cloud scheduler with a JSON message payload. And from the pub sub topic into the Cloud Run service, we're launching a singular centralized Docker image that can accept the message that we're sending from the cloud scheduler. And within that message body, we know which script we want to execute, which is the bit that makes it dynamic. So once we initialize our VM with the container, inside that container, we're going to execute a step to download all of the Python requirements dynamically and then execute the script we want from that message environmental variable. There's a lot of advantages to this, so we're going to have way less Docker images to maintain. So imagine if you had 100 pipelines, that's 100 less Docker images to maintain. The only thing you're concerned about is maintaining code, which is way simpler. The only downside is you're going to add maybe 2 to 3 minutes of extra runtime because you're going to have to run a Python installation of all of your requirements as soon as you execute the pipeline. But it shouldn't really matter in the scenario like a batch pipeline. So yeah, that's a kind of like a high level summary. It will make more sense once we go into a little bit of the details, hopefully. I think we'll start off with the GCS bucket. So we've got our list of buckets here. All of my stuff goes into this chess deployment bucket, which is what I synchronize with my GitHub production branch. And you can see everything is in here. It includes all of the functions my Python scripts use and the requirements and the Python scripts themselves. So just to show you, as an example, we have this test pub sub message script. If we hit download on it, you can see the contents of that Python script. In terms of how we're creating this singular Docker image to orchestrate any Python execution, I'll just have to go into the Docker file to show you how it's constructed. I've made a directory called GCS Python Executor. And I'm going to show you the Docker file to show you how I've constructed it. And essentially I'm using a slim version of Python as the base image. And I'm installing the gcloud utils and the gsutil so I can interact with the various APIs on GCP. I've also added Vim so we can do troubleshooting inside the Docker container. And we got JQ since we're doing some kind of text processing on some JSON strings that we're bringing through from the pub sub messaging system. So yeah, that is all the software requirements we need for the image. We put everything in the scripts directory, and we're adding a shell script to execute. When this bash script executes, this is what's going to be triggering your Python script later on. And I'll show you the contents of this shell script. So we're going to be searching inside the bucket with our deployed production scripts. And we're going to make sure that we have the relevant credentials to execute against the environment. And then we're going to run a gsutil command to copy the files from the bucket to the container inside the destination directory, which is the scripts directory. So it's going to copy everything into the scripts directory, and it should contain a requirements file within that deployment bucket. So after we copied all the files, we can do a pip install of all the requirements, since the requirements file is coming from the GCS bucket. We need to find out which script are we trying to execute in the process. So we're sending a message from the cloud scheduler. It just happens to be base64 encoded. So in this bash script, we need to decode the message. It's going to give us a JSON payload. And then we can use that JSON payload and run JQ across it to extract the value from the script name key. And that's going to tell us which script we need to execute in this process after triggering the cloud scheduler. So after we extract the script name, we're simply going to run that Python script. So that pretty much tells you what you need to know about how the Python scripts are being triggered once this Docker image is up and running. In terms of the artifact registry, what it means is we can eliminate all the old workloads that were previously baking in all of the Python code and baking in all the Python requirements. So we can simply simplify down to this GCS Python executor. So even if I have 100 pipelines, they can all funnel into this singular Docker image, and the only configuration I need to add is to add the relevant script name into the cloud scheduler to execute the correct thing. I think the best way to demonstrate how this works is just to simply execute a cloud scheduler instance to show you what is being executed and how that's functioning in production. So we've got this cloud scheduler job. I'll use this test pub sub message job as an example. I'll just dive into it to show you the contents. You can see we've presented a message body here. So the job name is the GCS Python executor. That's the Docker image we've listed inside the artifact registry. But the name of the Python script is called testpub_submessage.py. And that's what's going to determine what's being executed from that deployment bucket inside GCS. So what we'll do is we'll just force run this job, and then we're going to monitor in the logs what's going on, what's being executed minute by minute. And it's going to take a bit of time, since this execution process is going to take a bit longer. We've received the message from the cloud scheduler job, and it looks something like this when it's encoded. And after decoding, we have the script name. And that script name is going to get plugged into the Docker image inside the virtual machine, and eventually it's going to execute itself. So it's going to take a bit of time because we need to download that image from the artifact registry into the virtual machine, and then we just need to wait for all the Python requirements to be installed, and then we're pretty much good to go. Okay, so at this point, after it's finished fully installing that image into the virtual machine, we finally got the Python requirements being installed into the container. And yeah, so after we've wrapped up the requirement installation, we can see that the Python script has executed and it's passed out these print statements into the logging system. And yeah, after it's wrapped up these scripts, it's just deleted the VM and just cleaned up that process. So yeah, that pretty much wraps up what I wanted to show you. It's a bit of a convoluted process. Obviously, you can do this in a much simpler way just by using a Cloud Run service to run all of your ETL. But you know, it's nice to know different ways of doing things. So just thought I'd share that with you. Yeah, that's pretty much it. I'll see you guys in the next one.